Hi everyone, welcome back. Now let's try to solve the problem using my approach. Okay, if you aren't able to solve it, that's completely fine. You just need a bit of more practice. So let's look into how would I approach the problem and how would I solve it out. So the problem statement was from the features we have to find out the quality of wine. Okay, specifically red wine. Okay, and we had actually the quality score ranges from 0 to 10, and we have to actually convert it in a way that we are able to predict only good or bad. We need only binary classes. Okay, not multi-class but binary class. So let's start by importing all the libraries that we need. Let's import pandas as pd, numpy as np. Okay, next thing is let's import cborn as sns. Okay, we have pandas numpy c1. Let's import matplotlib dot pyplot as plt and matplotlib inline. Okay. Okay. So we specifically have all the necessary libraries that we need in the starting. Okay. Uh, mat. Yeah, now it's fine. So we have the libraries. Let's import our data set. Okay, let's import it as wine is equal to pd dot read csv, and the dataset name is, if we have a dataset, this is our dataset, wine quality red csv. Let's pass this out. Let's try to check what we are getting. As you see, we have all the features, and the last column is our target column. Okay, target, which is having all the target values, okay, quantity, basically the quality ranging from 0 to 10. Now let's do a bit of eda before changing the values of quality, okay, into good and bad. Okay. The first thing, as I always tell you, the one thing that I always love to do is describe. Before that, let's pass info just to check if we have any empty values. No, we don't really have one. Let's do wine.describe. This gives me a bit of information, insights about our data, what I'm looking into, what's the maximum, minimum, and also a bit of the distribution. As you see, the fixed acidity, the minimum is 4, the maximum is 15. And you can see the 25% of the data over here lies in less than 7. 50 is again on 7. So 25 to 50% of the data. Most of my data is lying between 7 to 9. Oh, 7 to 9. So you can actually plot it out using a histogram. So let's do wine dot hist, and let's pass bins. I think that should be enough. It will take few seconds to load out. Okay, the space, let's change a bit. Let's change fixed size. Fixed size is equal to, let's give 12, 10. That should be looking fine. Okay, you can increase the bin size also. Let's increase the bins equals to, let's give 20. Let's wait until it loads out. So as you see, as I've told you that for fixed acidity, most of my data is lying between 7 to 9. So see, 7 to 9, we have most of the data. This is the range where this space, okay, this is somewhere 7, I guess, 6.57. Yeah, 7 somewhere over here. And here it is 9. So 7 to 9, most of my data is lying. Same thing, you can see the uh, distribution of each and every, and we can also see the quality count plot for the quality. And you, as you see, this is a highly imbalanced data set. As for 3 and 4, we have so less value points, but for 5 we have so many. Similarly for 6, 7, 8, for 6 we have so much, and 7 and 8 we have so less. Okay, let's try to do a bit of plot bit more plots. Let's put a bar graph between wine. Let's take wine quantity, quality, and let's put it out with data. Wine. Let's try it out with alcohol. How they are relating. Okay, this gives me a better picture. See, again on x-axis we have quality. You can actually do something like this, plt.x label, just to have a clear picture if anyone else is looking into your data. Quality, and plt.y label as our alcohol level. There's a typo. Let's wait until it gets executed. So you can see the distribution of quality with alcohol. Okay, that's fine. Same. You can also put a box plot just to see uh, the outliers. Okay. Same thing. We have SNS dot box plot, SNS dot box plot, and let's have this thing wine quality. Pass it out over here, and here we have a box plot. You see at wine quality 5 we have some outliers. Okay, but we have, so one thing that we could really recall is, with high quality wine has high quality alcohol. Okay, as the alcohol level increases, the wine level also increases, right? The wine quality also increases. So yeah, that's a good way to look into it. Same thing, let's try it out with some other. We have seen it for wine alcohol. Let's look into volatile acidity. Hmm. So over here you can see that as the quality increases, the volatile acidity is quite decreasing. Okay, it's quite inversely proportional to it. Same thing, you can look it out with sulfates and the other qualities too. Hmm. See, we have a lot of outliers over here. Now, just so you know that let's not clean much over here. Okay, that's if you want to clean the data, it's on you. Clean out the data, and I'm pretty sure that you will be getting a much better solution than me. As of now, let's do start with the encoding part. So as I've told you that quality, let's look into quality, and wine quality, and let's do value counts. So we have 5, 6, 7, 4, 8, 3. So basically 3, 4, 5, 6, 7, 8. We don't have 1, 2. So we can have a logic that if the wine quality is in the range 3, is in 3, 4, 5, okay, then it will be bad. Okay, and if it is having the quality as 6, 7, 8, the rating, quality rating as 6, 7, 8, it will be having good, right? We'll just convert that each and every row. Okay, something like this. So we have the wine dot head. Let's look into the data set for 5. As of 5, as I said, if the value of quality is 3, 4, 5, it should be bad. 6, 7, 8, it should be good, right? Let's go ahead with this logic. Let's do data dot quality wine dot quality, and next thing is we are going to uh, wine dot quality again. uh, let's map a function to it, map, and I will map an dictionary to it, 3, For 3 it should be bad. Okay, same thing for 4. 4 again it should be bad. Again for 5 it should be bad. Okay, so for 3, 4, 5 it should be bad. The next one is again for 6, 7, 8. So for 6, as I've told you, it should be good. 7 also it should be good. And as for 8, for 8 also it should be good. Right, we have only 6 values over here. So this looks good. Let's check wine dot head. Okay, yeah, looks fine. So over here we had 6, so 6 is good. If you want to check the value counts, you can check it out. Yeah, so 854 and 744. This looks completely fine. Okay, the next thing that I need to do is I need to encode them. Okay, good as 0 and bad as 1. Okay, I can do it manually. Okay, I can use any the label encoder also, or else I can do it manually simply from this method, map by mapping again. Okay, as of now, let's use out the label encoder method just to have a quick revision of that. So from sklearn dot pre-processing, let's import label encoder. Label encoder, right? And we are going to transform the data wine dot quality is equal to, let's one thing that I forgot is to create a class of this. Let's do label encoder. We created an object of this class. Next thing is le dot transform, and I am going to take the complete data wine dot quality. Not fitted the label encoder. Okay, we have just forwarded out to fit. Let's do fit transform. Now if I check wine dot head, should be getting, yeah, 001. And same thing, let's do value counts. If I do value counts, so I have 855 and 744, exactly what we are getting. So 0 is good, 1 is good, and 0 is bad.